Hi guys, this is our second try at this, and today we're going to be learning about finding zeros of polynomials and writing polynomials. The first part of this lesson just begins with some vocabulary. The idea that zeros, factors, solutions, intercepts, and roots are all basically the same thing, just written a little differently, but basically they are where this graph intersects the x-axis. So when we talk about a zero, usually we write this something like, it'd be x minus k. When we're talking about the k, that's going to be our zero, okay? Same thing. The k is the zero. This whole entire thing, this x minus k, that whole thing is the factor, okay? And if we set that whole thing equal to 0 and solve for it, so you get x equals, let's say, 5, that's going to be a solution. And then, of course, where it crosses the x-axis is going to be at k0, or in this case, it'd be like 5, 0. Okay, so let's try this in action here. All right, if we're looking at this graph to the left here, you should notice a couple of things. It's got two turning points, right? Two turning points. It intersects the x-axis at 1, 2, 3 places. Okay, so those are going to be our solutions, our factors, our x-intercepts, our zeros. Okay, and as you see, here they are, -1, 2, and 4. And then if we write that in factor form, remember, it's the same as saying x minus a -1, so that's why it becomes x plus 1. And we just put these numbers into the factor form. In solution form, this is what they look like here. And then x-intercepts, remember, when it crosses the x-intercept, y is going to be 0. So we just write the solution. This is going to be your k, and then 0. Okay? So let's try that. So you're going to need to go to your calculator for this. And here it comes. And you're going to graph this equation on your calculator. Okay, so let me clear mine out here. So when you graph this, it looks like this. X to the third minus 3x plus 2. Okay, and my graph looks, looks something like that. Okay, I'm having a hard time seeing it. So I'm going to make my window a little bit bigger so that I can really see the whole picture. Okay. So as you can see, it goes through, it looks like -2, and then it touches down at 1 and then comes back up. So what I'm going to do is I'm going to graph that on my piece of paper. And this is really a sketch, so it doesn't have to be perfect. But it does go through at 2, and you can verify this on the table, okay? And then it actually turns around somewhere around like right here. So it kind of comes up like this, and then comes back down, and it actually touches on there and turns back around and goes the other way. Okay? Looks something like that. All right. So we talk about degree, okay? It's the highest exponent, so the degree is 3. Excuse me. It has how many zeros? It has 1, and then remember, this one counts as 2. That's its 2 solutions, okay? So there's 2 zeros still, okay, at -2 and then +1. Those factors look like this. Remembering again that the -2 becomes a plus. The solutions look like this. X equals -2 and x equals 1. And our x-intercepts are at -2, 0, and 1, 0. Okay, multiplicity we've never talked about before. But multiplicity is the number of times each of the zeros occur. So the multiplicity of, let's for example, -2 is 1. The multiplicity of 1, this 1, 0, is 2. Do you see that? Because it happens, it counts as 2 solutions. Okay, let's move on. Okay, so the second example is a little bit different because this one has real solutions, but it also has some imaginary solutions. So again, you're going to go back to your calculator and graph that. So you're going to go back here and plug that in. So you get x to the third. Now, because it's x to the third, how many solutions will it have? Hopefully you're saying 3 at the moment. It should have 3 solutions because it's x to the third. Okay, let me see if I can talk and do this at the same time. Okay, make sure you put this in correct, and then graph it. Okay, notice, this graph only goes through the, x-axis, one time. And you can check where it goes through on your table. It's somewhere at x equals, it looks like 7. Okay, at x equals 7, then y is 0. So that's where our x-intercept is. So you're going to actually use that. Okay? So it goes through 1, 2, 3, 4, 5, 6, 7, right about here. It kind of looks like this. Just a rough sketch of that. Okay, this is degree 3. Okay? The zeros we know of right now is just at 7. So let's write that in. Okay? My factor for that is going to be x minus 7. Okay? So the number of real solutions I have now is just 1. 1 real solution. Oops, sorry, that's the wrong place. Okay, the real solution that I have is 7. Okay? The x-intercept is going to be at 7, 0. Okay? So the number of real solutions is 1. My imaginary solutions is 2. And we're going to solve for that right now. All we know right now is that we have a solution of 7 as one of the solutions. So we're going to use synthetic division to do this. So if I rewrite my equation down here, it looks like this. F of x equals x to the third minus 17x squared plus 96x minus 182. And if you remember, we have to make sure that all of the exponents are accounted for. In this case, 3, 2, 1, and then 0. So we're good. So we're going to just recopy just the coefficients. So 1, negative 17, 96, and negative 182. And then we are going to divide it by our solution, which is 7. Okay, so we're going to do this because we're going to make our polynomial smaller by doing that. So we're going to divide by 7. So we're going to bring down the 1. 7 times 1 is 7. Add those together. You get negative 10. 7 times negative 10 is negative 70. Add those together and you get 26. 7 times 26 is 182. And we know this goes in evenly because it's a root. So we get 0 here. Now, if we were to rewrite this using our synthetic division, we would get x squared minus x plus 26 as our new function, okay, that we're trying to find the roots for. Now we're going to have to use the quadratic formula for this. So a equals 1, sorry, b equals -1, and c is equal to 26. All right, so when you substitute this into the quadratic formula, you get 1 plus or minus the square root of 1 minus 4 times 1 times 26 all over 2 times 1, or just 2. So you get x equals 1 plus or minus 1 minus 103, all over 2. Or, this is a lovely problem, as you can see. You get 1 plus or minus the square root of -102 all over 2. Now 102 can be reduced. Okay, we can divide 2 into this and you get 51 times 2. And 51 is can be divided by 3. We get 3 times, let's see, there's 1 time 2, so 17. So these are actually, there are no pairs, so this is in lowest form. So what you get as your final answer is 1 plus or minus the square root, or I square root of 102 all over 2. And that actually is in lowest form. So if you were to list all the zeros here, the zeros would all be 7, and then you'd get 1 plus I root 102 over 2, and then 1 minus I root 102 over 2. And so that's how you're going to use synthetic division to simplify this equation. Okay, now go ahead and try number 3 on your own. Okay. Again, you're going to have to graph this. When you graph it, hopefully you're going to get a 0 where it goes through the x-axis. So go ahead and do that on your own, and then I'll put up the answer and you can check it. Okay, I put the solution up for you, and you can pause and look over this, but basically it's degree 4. When you graph this, it looks something like this. This is a pretty rough sketch of this, but basically it goes through the x-axis at -1 and 2, which gives them my two first zeros. You're going to actually use synthetic division twice using those solutions. So you start with the original equation here, and you set up synthetic division, and I'm going to put the 2, which is one of the solutions, in first, and get this new equation that's right here, that I rewrote up here, okay? And then I'm going to use synthetic again with the second solution, and so I keep making this polynomial smaller by doing that. And eventually you get down to this equation right here by using the numbers that I got from doing the synthetic above. And you use that to use the quadratic formula again, and you end up with forced solutions, which is exactly what you want to get. Okay, so the rest of the notes for this is review of writing equations. So I want you to try those on your own and finish up, and I will put the answers up in a few minutes, so pause and go ahead and do this, and I will post them in a minute. All right, so here's the solutions for the first 2. If you need to pause to look at them, go ahead. And then here are the solutions for for number 3, and I'm going to let you do 4 on your own. And again, if you need to pause to look it over, go ahead and do that. All right, that's it. Thank you.